NASA just confirmed. OSIRIS-REx found something impossible on Bennu. Right now, while you're listening to these words, something is happening that almost nobody on Earth knows about. It is no larger than a city block. It drifts through space in complete silence, more than 300 million kilometers from Earth. It has no atmosphere, no rivers, no weather, and yet, something on its surface appears to be changing. Not over millions of years, not over centuries, but while we are watching. It is not a planet. It is not a moon. It is not even large enough for gravity to hold someone standing on its surface without help. It was already traveling through the darkness long before smartphones existed, before the internet connected the world, before the first reusable rockets ever left the launch pad. Imagine holding a single teaspoon of black sand. Now imagine that tiny handful preserving secrets older than every mountain, every ocean, and every living thing you have ever known. That is the scale of what scientists believed they were bringing home. Instead, they may have carried back evidence that forces us to ask a much stranger question. What if small worlds are not as silent as we thought? The researchers are not celebrating. They are arguing. Some call the evidence astonishing. Others call it baffling. A few quietly admit that one assumption they trusted for decades may have been wrong. This is the story of Bennu. More precisely, this is the story of what the fictional version of the OSIRIS-REx mission discovered after returning its sample. And here is the part the headlines are not telling you. It is not just what the mission found, it is what that discovery could mean for every rocky object drifting through our solar system. It is what appears to be happening on Bennu right now, years after the spacecraft departed. And it is what might happen during the next mission already being planned. Stay with me, because by the time this story is over, you may never think about an asteroid the same way again. Every great mystery begins with something ordinary. For this one, the ordinary moment arrived in 1999. A team of astronomers working with the Lincoln Near-Earth Asteroid Research Program scanned image after image across the night sky. Among thousands of tiny moving points of light, one object stood out. Not because it was bright, not because it looked unusual, simply because it moved. It received a catalog designation. Another small asteroid among hundreds of thousands already known. No one imagined that one day humanity would travel to it. Years passed. Computers became faster. Telescopes became sharper. Astronomers tracked the object's orbit again and again. Each calculation became more precise. Eventually, they gave it a name: Bennu. At first glance, Bennu appeared almost disappointingly simple. Roughly 500 meters across, dark, rocky, covered with loose debris, a spinning pile of rubble, held together by surprisingly weak gravity. If Earth were the size of a basketball, Bennu would be smaller than a grain of sand. Yet something about that grain of sand kept attracting attention. Tiny adjustments in its orbit refused to behave exactly as expected. Nothing dramatic, nothing impossible, just enough to remind scientists that even the smallest worlds still keep secrets. NASA made an ambitious decision. Instead of studying Bennu from millions of kilometers away, why not go there? Why not touch it? Why not bring part of it home? The project became known as OSIRIS-REx. Origins: spectral interpretation, resource identification, security, regolith explorer. An extraordinarily long name, an extraordinarily difficult mission. The spacecraft launched aboard an Atlas V rocket. Its destination was a world that, despite its size, represented one of the oldest surviving building blocks of the solar system. The journey covered hundreds of millions of kilometers. Unlike a mission to the moon, there would be no direct landing, no astronauts, no repairs. Every command would travel across space at the speed of light. Every correction depended on software, mathematics, and extraordinary patience. As OSIRIS-REx approached Bennu, something unexpected happened. The asteroid refused to match the neat models prepared before launch. Scientists expected relatively smooth regions. Instead, the spacecraft found chaos: towering boulders, sharp ridges, jagged terrain. Imagine planning to land in a flat parking lot, only to discover an entire mountain range waiting instead. Every landing strategy had to change. Navigation algorithms were rewritten. Engineers practiced again. Mission planners debated every meter. Failure suddenly became a very real possibility. But eventually, one location appeared just safe enough. Barely. The target area was so small that hitting it accurately became one of the most demanding navigation exercises ever attempted. The spacecraft rehearsed, then rehearsed again. Every maneuver depended on calculations, so precise that even tiny errors could send the vehicle crashing into rocks or drifting away forever. For years, everything had been building toward one brief moment. Touch, collect, leave. Just a few seconds. That was all the spacecraft would have. Billions of dollars. Years of engineering. One opportunity. Then came the descent. The engines fired gently. The cameras locked onto landmarks. Bennu slowly rotated beneath the spacecraft. Closer. Closer still. Dust filled the camera view. The sampling arm extended. Contact. For only an instant. Then compressed gas blasted material upward. The spacecraft backed away. Mission control erupted. By every measurement, the collection had succeeded, or so everyone believed, because according to this fictional account, the real discovery would not begin on Bennu. It would begin years later, inside a laboratory, after the sample finally returned to Earth. And that was the moment everything changed. The sample capsule landed exactly where engineers had hoped. Years of planning ended with a parachute drifting across the Utah desert. From the outside, nothing looked extraordinary. A metal capsule, dust, silence. Inside, however, sat material older than Earth itself. At least, that was the expectation. Scientists transported the sealed container into one of the cleanest laboratories ever built. Air moved through layers of filters. Every tool had been sterilized. Every particle entering the room was carefully monitored. The goal was simple. Do not allow modern Earth to contaminate ancient space. Because once contamination happens, the original story is gone forever. Researchers opened the container slowly. Black grains shimmered beneath bright laboratory lights. Some were no larger than grains of pepper. Others resembled tiny fragments of charcoal. Each particle represented billions of years of history. Every grain became its own investigation. Powerful microscopes revealed crystals. Spectrometers identified chemical fingerprints. Electron beams mapped individual atoms. Step by step, the story of Bennu began unfolding. Atoms are enough to build minerals. Minerals combine into rocks. Those rocks break apart. The fragments collect into loose regolith. That regolith preserves records of every collision, every burst of sunlight, and every violent event the asteroid has survived. Think of it as a library, not one filled with books, one filled with dust. Every grain is another page. Every crystal, another sentence. Every microscopic fracture, another forgotten chapter. That is why sample return missions matter. Telescopes only observe the cover. Laboratories can finally read the pages inside. At first, everything appeared wonderfully familiar. Carbon-rich minerals, hydrated compounds, ancient silicates, exactly the kinds of materials scientists hoped to study. Then, something refused to fit. One instrument measured an unusual crystal pattern. Another confirmed it. A third disagreed completely. Calibration checks followed. The equipment passed every test. The sample remained unchanged. Scientists repeated the experiment. Again, again, again. The same contradiction returned. It looked as though one group of minerals had formed under conditions that should never have existed on a body as small as Bennu. Researchers checked the containers. Nothing. They checked the storage chambers. Nothing. Software logs. Nothing. Months passed. Nobody announced anything publicly. Not because anyone wanted to hide the result. Because extraordinary claims demand extraordinary caution. Every explanation had to fail before a stranger possibility could even be considered. Imagine opening a history book about ancient Egypt, only to discover one page describing a modern skyscraper. Your first assumption would never be time travel. You would assume the page had been inserted by mistake. That was exactly how scientists approached the mystery. The impossible explanation came last, not first, because science always starts by trying to prove itself wrong. Understanding Bennu had never been easy. Even reaching it had tested the limits of engineering. At its greatest distance from Earth during the mission, radio signals required many minutes to cross the gap. Every instruction traveled alone. Every confirmation arrived long afterward. There were no joysticks, no live steering, no second chances. Imagine trying to park a car while looking through a camera that only updates long after every movement you make. Now imagine doing that hundreds of millions of kilometers away. That was the challenge. The spacecraft itself never knew whether a command had succeeded. It simply followed instructions, patiently, precisely, without hesitation. And once it left Bennu, There was no turning back. The precious sample rested inside a sealed return capsule. Nobody could open it in space. Nobody could inspect it. Nobody could repair it. If something had gone wrong, humanity would have discovered the failure only after the capsule returned to Earth. Years later, that uncertainty followed the mission home. Engineers trusted their instruments. Scientists trusted their measurements. Yet everyone understood one uncomfortable truth. Nature has no obligation to match our expectations. That is why every surprising result triggered another wave of testing. Every instrument had an independent backup. Every laboratory repeated the same measurements. International teams compared data. Arguments filled conference rooms. Not because anyone wanted to reject the evidence, because everyone wanted absolute confidence before accepting it. In this fictional story, that confidence arrived slowly. One observation became two, two became six, six became dozens. Every new measurement pointed toward the same unsettling conclusion. Some microscopic structures appeared to record an event that existing models of Bennu's history simply could not explain. Not impossible, just unexpected. Researchers built simulations. The simulations failed. They adjusted temperatures. The models failed again. They changed pressure. Still failed. Different chemical environments. Failure. Different impact histories. Failure. Every answer solved one mystery while creating another. Eventually, one scientist quietly asked a question nobody wanted to hear. What if we are trying to explain the sample using the wrong history entirely? The room became silent. Not because anyone believed the idea, because everyone realized it could no longer be dismissed immediately. That single question changed everything. Instead of asking how Bennu formed, researchers began asking where every individual fragment inside Bennu had originated. And suddenly, the asteroid no longer looked like one world. It looked like a collection of many forgotten worlds, broken apart, mixed together, and frozen in time. If that interpretation proved correct, then Bennu was not simply preserving history, it was preserving multiple histories, each fragment carrying a different story, each story beginning somewhere else in the solar system. That possibility transformed every grain of dust into something far more valuable than anyone had imagined. Because if even one fragment retained evidence from a completely different environment, then Bennu had become less like an asteroid and more like a cosmic archive. An archive assembled over billions of years, one collision at a time, and according to this fictional account, the deepest mystery was still waiting beneath the microscope. The first anomaly had only opened the door. The second would challenge every explanation that came before. The first anomaly was strange. The second was unsettling. The third refused to disappear. Weeks turned into months as researchers compared thousands of microscopic images from the Bennu sample. Every grain looked unique, until someone noticed that a handful of crystals shared the same internal arrangement. Not the same composition, the same geometry. Imagine finding identical fingerprints on rocks collected from opposite sides of a mountain. Possible? Perhaps. Expected? Not even close. The team built a digital map of every crystal. One by one, the strange structures appeared. Then another. Then another. At first, they suspected contamination. Fresh instruments were brought in. New laboratories repeated the measurements independently. The same pattern appeared again. In this fictional scenario, the crystals behaved as though they had all experienced the exact same event, long before Bennu itself ever existed. That idea sounded absurd. Bennu is widely understood to be a rubble pile asteroid, a world assembled from fragments left behind after a much larger parent body shattered billions of years ago. If that understanding were completely correct, why would unrelated fragments carry nearly identical microscopic scars? Researchers still could not explain it. Every simulation solved one piece of the puzzle while breaking another. The mystery remained. One scientist suggested a different way of thinking. Perhaps these tiny rocks were not simply pieces of one asteroid. Perhaps they were witnesses. Every collision leaves a mark. Every burst of radiation changes atoms. Every close encounter with another world writes another chapter into the rock itself. Like tree rings recording seasons, or layers of ice preserving Earth's climate, ancient minerals can preserve memories of environments that vanished billions of years ago. That possibility transformed the investigation. Instead of asking, "What is Bennu made of?" the question became, "What has Bennu survived?" Computer models reconstructed impossible journeys. fragments drifting through the young solar system, violent collisions, long periods of darkness, close passes near the sun, billions of years of quiet travel. Most simulations failed, but each failure narrowed the possibilities. Researchers were no longer looking at one story. They were assembling millions of tiny pieces from a cosmic jigsaw puzzle, and one piece seemed determined not to fit anywhere. Then came the grain. It was almost too small to see without magnification. Dark, angular, completely ordinary in appearance. Yet every instrument told a different story. One suggested it formed under extreme heat. Another suggested extremely cold conditions. A third hinted that both histories might somehow be preserved inside the same microscopic fragment. That should not happen. Not according to any existing model. The laboratory repeated the experiment. Again and again. Nothing changed. In this fictional story, the researchers reached an uncomfortable conclusion. Perhaps they were not looking at one uninterrupted history. Perhaps the grain had been broken apart, altered, reassembled, and altered again over immense spans of time. Imagine discovering a single page containing handwriting from different centuries, written with different inks, yet somehow occupying the same sentence. That is what this grain resembled. Not impossible because of the material itself. Impossible because of the sequence of events it appeared to preserve. Around conference tables, debates stretched late into the evening. Some argued the data had to be incomplete. Others believed an unknown process was responsible. A few wondered whether small asteroids had lived far more complicated lives than anyone had imagined. Nobody claimed certainty. Nobody declared victory, because every answer still rested on evidence that demanded extraordinary care. One fact remained clear. The Bennu sample, at least in this fictional account, had become far more than a collection of ancient dust. It had become a mystery, and every new measurement seemed to deepen that mystery instead of solving it. The investigation was no longer about proving one hypothesis. It was about discovering which impossible explanation would fail last. The biggest surprise, however, was still ahead. Because the next experiment would not study the rocks alone. It would study how they changed over time. And that was the moment the investigation entered completely unknown territory. The next phase of the investigation was never supposed to produce surprises. The goal was simple: observe, record, compare. Researchers photographed several microscopic grains over weeks. Nothing unusual was expected. After all, rocks do not change simply because someone is watching them. Except one appeared to. Not dramatically, not visibly to the human eye. Only under instruments capable of measuring changes smaller than a wavelength of light. In this fictional story, one crystal seemed to rearrange its outer structure ever so slightly after repeated exposure to controlled laboratory conditions. The change was tiny, almost meaningless, until it happened again. Imagine photographing the same mountain every morning. Everything should remain exactly where it was. Now imagine discovering that one cliff has shifted by a few centimeters overnight. Not enough to notice at first, enough to make you question every photograph that came before. The researchers checked for heat, nothing unusual. They checked for vibration, nothing. They checked humidity, electromagnetic interference, chemical contamination. Every ordinary explanation came first. Every ordinary explanation failed. No one claimed the sample was alive. No one suggested anything supernatural. The mystery was simpler than that. The sample appeared to be responding to something the researchers had not yet identified, and they still could not explain why. Science rarely advances because someone proves an astonishing idea. More often, it advances because an ordinary idea stops working. That is exactly what happened in this fictional account. Every model describing Bennu assumed that its history could be reconstructed through known geological and chemical processes. Now, those models began leaving unanswered questions. Not because they were useless, because they were incomplete. Researchers built new simulations, different impact histories, different parent bodies, different thermal cycles, millions of combinations. Some came close. None explained everything. One scientist quietly summarized the problem. We may not be missing a measurement. We may be missing a process. That sentence changed the direction of the investigation. Instead of asking how Bennu became what it is, the team began asking whether small asteroids experience slow physical changes over billions of years that no mission has ever observed directly. It was an uncomfortable possibility, not because it broke physics, because it suggested physics still had another chapter to write. In the vast history of science, This has happened before. The universe did not change. Our understanding of it did. By now, Bennu no longer looked like a simple asteroid. It looked like a vault, a place where fragments from forgotten worlds had gathered over unimaginable spans of time. Every collision added another page. Every orbit preserved another memory. Every billion years sealed another chapter. Perhaps that is what made the sample so valuable. Not that it answered every question, that it asked better ones. Could other rubble pile asteroids preserve similar records? Could future sample return missions uncover entirely different histories? Could tiny worlds scattered across the solar system contain evidence of environments that disappeared before Earth itself had oceans? Researchers still could not fully explain the fictional anomalies presented in this story. But they agreed on one thing. The smallest worlds often preserve the oldest memories. Sometimes, the quietest places have the longest stories to tell. The real OSIRIS-REx mission has already completed one extraordinary achievement. Its samples will continue to be studied for decades. Future generations will use instruments that have not even been invented yet. In this fictional version of events, the mysterious grain remains locked inside a secure laboratory. Not because it is dangerous, because every new instrument reveals another tiny piece of its story. Meanwhile, new missions prepare to visit other asteroids. Each launch carries another opportunity, another question, another chance to discover whether Bennu was unique, or merely the first page in a much larger book. If similar patterns were ever found elsewhere, even in fiction, the implications would stretch far beyond one asteroid. They would suggest that the solar system has been quietly preserving its own autobiography all along, waiting for someone patient enough to read it. So what does all of this actually add up to? Perhaps not proof of something impossible, perhaps something even more exciting, a reminder that every answer creates another question. One small asteroid, one returned sample, one investigation that refused to end where everyone expected. The universe rarely reveals its secrets all at once. Instead, it offers fragments, pieces, clues, and leaves us to decide whether we are curious enough to keep searching. Beyond Bennu are millions of other asteroids. Beyond them are countless moons, planets, comets, worlds that no spacecraft has ever visited. It is genuinely worth wondering what stories they might be hiding too. If you enjoyed this fictional exploration, inspired by the OSIRIS-REx mission, subscribe and turn on notifications. Here, we explore imaginative space stories alongside real scientific inspiration, always making the distinction clear and celebrating the spirit of discovery that drives space exploration. Because the greatest mysteries are not always the ones we solve. Sometimes, they are the ones that inspire us to keep looking.